All right, Ag Mechanics, welcome back. It's Monday, November the 30th. If you missed class today, there's a couple things posted in our modules. We are only working on the electric principles today. But before we begin, the first thing, don't forget that our measurements are due today. This gives you almost 2 full weeks to have this completed. I will be checking these very early in the morning to make sure you get them completed today. One student said that they didn't know exactly where they were, which is a little bit confusing. So right above our Unit 4 module, just to recap, our housing data measurements. When you open that up, you will find the spreadsheet that has all of the information that you are required to put in. As you know, you can add or subtract things depending on your house. That is completely fine. What we are working on today, I created its own little module for electricity because we have a lot of different things in there. So we're in the 4.0607. There is going to be an electrical tools identification, and that is active. We did not go through that today. So all we did is go through part of our outline and notes today. So if you open up your outline, you'll see that it is a very short outline. So I just want to go over some today. So get this thing rolling. Basically, what we're doing today is we are looking at some basic terms. We discussed a couple things. So electric principles, the big three are amps, watts, and volts. Amps is how fast something goes from point A to point B. Volts is how much pressure is on the inside of your actual wire. So the current, the pressure of your current. 110 is what everything is plugged into your house. So the outlets that you plug your phones into, lamps into, those are all 110. There are a couple things that has to have 220 volts in your house. That would be your oven / stove, your dryer, your hot water heater, and if you have a heat pump. Those require more electricity, so those are 220 volts. Watts is the measurement of electrical power. If you think of horsepowers for cars, watts is just that for electricity. Kilowatts is 1,000 watts. So when your parents get that power bill every month, right, and they're yelling at you to turn off the lights, right, that's measured in how much electricity you use, which is watts, right? So kilowatts is how you actually compute cost. There are 3 basic kinds of circuit protectors: fuse, fusetrons, and then circuit breaker are 3 types. Basically, what happens is when too much electricity is pulled through there, it trips and stops the flow of electricity. This is a panel box, circuit breaker box. You have one of these in your house. It could be in a garage, a bedroom, closet, laundry room, but every house has one. Every circuit breaker that's on here is going to tell you how much amps, right, or how much electricity is able to flow through them. Okay, that's what it looks like when it's pulled out. So this one is a 15 amp. Once again, it's going to tell you on the actual circuit breaker itself. Fuses, if you've ever changed a fuse in your car before, those real small little plastic ones where it has that metal strip, when too much current passes through, that strip melts. And when that happens, it stops the flow of electricity. So we have plugs and cartridges. This is a cartridge, right? It's pretty simple. It looks like, if you think of a shotgun shell, right, it's also called a cartridge. It's an easy way to remember that, right? And there are some special ones called fusetrons. Fusetrons are a fuse where it's designed to carry a temporary overload. So if you think about a welder, it's plugged into a 220 volt receptacle, right? And when you first flip that on, it pulls a lot of energy. So that fusetron allows for that brief delay until it comes back down to normal operation. So the way it would work is if it carried that same high current or those amps for longer than, say, a second, it's going to automatically break and disengage the electricity, so that way there's not an accident. A conductor, I feel pretty confident that y'all know a conductor and an insulator. Anything that's going to carry electricity is a conductor, and an insulator is anything that's going to prevent the electricity going through it. The most common two are rubber and plastic. You can find some porcelain insulators out there as well. Whenever you're wiring, we have a hot wire, a neutral wire, and a ground wire. Typically, your hot wire is going to be red and black, and your neutral wire is typically going to be white. Your ground wire, if there is a short, what that is designed to do is carry the electricity back to the earth. That way you don't get shocked or electrocuted. Depending on the kind of wire you use, this could be just a brown, or excuse me, a bare copper wire or green coated wire. So typically your ground is going to be green or just a bare wire. And then ohms is where we stop today. Ohms is what you use to measure the resistance of electricity. So today, fill out your outline to this point, and then you need to complete all of the measurements for your house. We're going to start using these here in a couple days, so it's really important that we get that knocked out. Okay. Does anybody have any questions or concerns? If you do, go ahead and hit me up on some email, and I'll get back to you as soon as possible. Y'all have a great day, and I'll see you back here on Tuesday.